Hello wonderful person, this is Anton, and today we're once again going to discuss some of the new and somewhat disturbing discoveries in regards to microplastics. Something that's becoming almost as ubiquitous as the air we breathe. And as a side note, actually is part of the air we breathe. This is something we've discussed in one of the previous videos, and the discovery there was just a little bit unnerving. You can find those previous discoveries in the description below. And while by now a lot of scientists agree that microplastics, or essentially these tiny particles and tiny fragments formed by larger plastics, have now become a kind of an environmental disaster. And to demonstrate, I actually wanted to start with this video. This is a really intriguing example that was discussed by Florian Hiemstra back in 2025, where scientists discovered that a lot of caddisfly specimens have now started to actually use microplastics as part of their natural cover, or basically they started to make their own clothes entirely out of microplastics in the water. But the more surprising discovery in this case was also the fact that they've actually been doing this since apparently at least 1971. In other words, even back then, they already started to adapt to this bizarre changing world. And so this picture right here is a more or less perfect representation of how ubiquitous microplastics have now become. We've essentially found them in some of the deepest parts of the ocean, on some of the highest peaks in the Himalayas, and it's pretty much everywhere around us and inside of us, which is of course what those previous videos were mostly about. But in a series of recent discoveries, including a major paper from May of 2026, scientists have now revealed a new and perhaps more subtle threat from these tiny particles. Turns out that they're not just bad for our health, they're also now apparently affecting the climate of the planet in ways we never actually expected. And so we now have some atmospheric discoveries to add to the list of why microplastics might not be such a good idea after all. And so let's discuss these new studies in a bit more detail, but I guess first let's briefly discuss what we've already known for many years. And specifically that microplastics are pretty bad for our health. They've now been discovered in most of the organs in our bodies, including brain tissue and of course lungs. But the recent study from Duke University along with the Fudan University has recently modeled how these particles also behave in the upper atmosphere. And in essence, they discovered that when microplastics are swept up by the wind, they start to actively interact with sunlight. And while interestingly, even though some of the light-colored particles can sometimes scatter the sunlight and provide a little bit of cooling, apparently the warming effect seems to be much stronger. In fact, the warming effect is at least 5 times stronger than the cooling effect, making microplastics a previously unrecognized factor when it comes to climate change. But one of the more interesting discoveries was also in regards to color, or essentially in discovering how color seems to have a major effect. And this is of course something that kind of makes sense. Darker colors usually become much warmer. If you've ever worn a black t-shirt on a sunny day, you know exactly what I'm talking about. And the same applies to plastics. Here the study discovered that colored microplastics, and especially black, blue, red and yellow, absorb a lot more sunlight compared to anything that's uncolored or white, with some of the dark color particles absorbing up to 75 times more sunlight than pristine clear plastic. And in this case, time is not on our side, because with time, a lot of plastics tend to age or become more yellow because of the UV light exposure, which actually makes them absorb even more heat, even though they might have had different color at first. And on a global scale, a lot of these tiny particles seem to trap nearly 1/5 as much heat as something like black carbon or soot, which is currently one of the most potent contributors to atmospheric warming. But in some areas, like the famous North Pacific garbage patch, the warming from these floating plastics is even stronger than the warming from local soot. In other words, in certain locations, it seems to be the predominant driver of heat and seems to affect the temperature way more than predicted. But that's just one of the effects they seem to have. Apart from this, a separate study has also found that microplastics are changing how the clouds form as well, specifically showing that microplastics now act as a nuclei, or basically these tiny seeds that ice crystals usually grow around, which then triggers ice formation even at temperatures 5 to 10 degrees warmer than usual. And while normally pure water can actually remain supercooled down to minus 38 degrees Celsius, the presence of these seeds usually causes the water to freeze and to condense into clouds or even form rain. And so the presence of microplastics in the atmosphere tends to trigger freezing much sooner. And this means that microplastics seem to also be able to alter precipitation patterns, possibly increasing rain or snow in places where it normally doesn't happen. And so by making it easier for ice to form, microplastics seem to also increase cloud cover in locations where they might have never existed. Now that could be of course good news because clouds tend to reflect light and thus cool down things, but at the same time this also creates a bit of a misbalance when it comes to water cycle. And so here they seem to shift the ratio between liquid water and ice and seem to shift the planetary energy balance. Now obviously exactly what they're doing is still unknown because these are new discoveries, but these studies definitively showed that they do seem to have an effect. Although unlike in the previous study that showed that aging plastics tend to heat up the planet, here the discovery was that aging plastics seem to be not as good at nucleation or formation of clouds compared to new plastics. And so yeah, in terms of the actual effects, we have no idea what this means yet. Moreover, we don't even know the exact concentrations of these particles at higher altitudes, and so the true impact on the global climate change is currently unknown. But there's also other discoveries from the interaction of microplastics with ice, and specifically when these tiny particles settle on glaciers, such as those in Himalayas, they seem to cause a phenomenon referred to as albedo reduction. Essentially, dark plastic particles make the white snow less reflective, causing the ice to absorb more heat and melt faster. And so they may also have an effect on deglaciation across the planet, with additional studies also discovering that even their motion across the planet seems to be much more hectic and much more unpredictable than we initially thought. And specifically, a 2025 study discovered that typhoons and hurricanes seem to act like a giant vacuum cleaner for the entire ocean, with these very powerful storms churning up microplastics from the oceans and then ejecting them into the air, which can then be dumped on land as these hurricanes make landfall. And so during a single typhoon in China, researchers measured a peak deposition of 12,000 plastic particles per square meter per day, which basically creates a kind of a dangerous feedback loop. The changing climates increase the number of storms, the storms become more intense, they start to recycle these microplastics into the atmosphere and on ice, and microplastics make the weather more unpredictable. Which is of course not something anyone expected a few years back. Back then, we mostly discussed health effects. So basically back then, we've only discovered that microplastics can cause inflammation and tissue scarring, with scientists even naming a new condition known as plasticosis, something that's now actually extremely common in seabirds, as many seabirds now contain a lot of injuries inside their bodies from the damage of microplastics. Although, as I mentioned in that previous video, it's now also been discovered in several brains of diseased patients that did die from something inside the brain, but it's not entirely clear if it was the plastics or something they caused as a result. In other words, this whole microplastic situation is only getting a little bit more dangerous. But they've definitely now been linked to increase in heart attacks and stroke, with several patients that have gone through stroke or heart attack apparently containing clogged arteries that were filled with microplastics. But apart from these individual risks, the risk is now slowly becoming planetary. And so even though we used to think of plastic as some kind of a dead waste, it seems to have now become a chemically active part of Earth's geophysics. But obviously, it's not all doom and gloom, mostly because there's also been additional discoveries and additional research on trying to figure out how we can maybe get rid of these microplastics once and for all. Now, this research is also still in its infancy, but for example, last year, scientists have discovered an unusual genetic marker inside certain bacteria referred to as M5 motif, something that seems to be present in certain marine bacteria that have now started to eat plastic. In other words, certain bacteria started to now adapt and started to use plastic as a food source. And so by studying these enzymes and trying to engineer them in order to break down plastics, we might find a way to get rid of them before it's too late. And though obviously some countries have also started banning plastics, at the moment that's also in its infancy, and with only some countries participating, none of this is helping yet. Mostly because microplastics tend to travel across international borders via wind and sea. And so unless there's some kind of a global treaty, none of this is going to help us anytime soon. But ultimately, these new discoveries that microplastics are also affecting the climate tells us that this is becoming a multifactorial problem. It's a problem for human health, it's a problem for the planet, and it's now affecting a lot of different species. And it's also a serious reminder that things we produce and things we use every day eventually change form and continue to influence the world in ways we're only beginning to understand. But because this is such a complex topic and because there's a lot of research in regards to this, we're going to come back and discuss this in the next few weeks, mostly focusing on additional health studies and additional discoveries. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.